Hey guys, Mr. Smith here, shooting a video on how we can interpret and handle exponents that are fractions or decimals. So in my class currently, the grade 11 3M3U split class, we've reviewed the basic exponent rules. We've reviewed what happens when exponents are 0 and negative. That was reviewed for the people that took grade 10 academic, but it was new for some. And then today will be new for everybody. In order to get ready for what we're doing today, and you'll just have to trust me on why this is necessary, we need to, on our calculators, get used to evaluating some roots that aren't square roots. So like most people have experience using their square root button, like from Pythagorean theorem and other grades. The square root of 121 is 11, and that's true because it's 11 times 11. That's equal to 121. Now, the third root of 8, you might be able to guess what that is without actually having to use your calculator. The third root of 8 is asking what number times itself 3 times gives you 8. And so most people can probably figure out that's 2. The third root of 8 is exactly 2. Now, if you're doing this at home, what you should probably do is kind of figure out where this button is on your calculator. For me, my button, and it's usually above your power button, I have a button that looks like this. It's the square root button with kind of an X tucked inside the little crook of the square root. It's saying I'm doing the xth root. I can do third root, or I can do fourth root, so on and so forth. So for me, if I was doing something like the cube root of 8, I would do, my keystrokes would be, I would press 3, then I would press my X root button, and then I would press 8, and then I would press equals, and it would spit out 2. Everybody's calculator is different. You'll just have to figure this out if you're at home, and then ask somebody when you get back to class. Let's continue. So just keep getting used to this button in your calculator. The fourth root of 81, what number times itself 4 times gives you 81. I think most people can figure that out, maybe with a bit more thought. Then part B, that's equal to 3. You should make sure you get that on your calculator. So you'd be doing 4 and then your X root button, 81. And then the fifth root of negative 2, unlike square roots, like you can't square root a negative number, but you can take these odd roots, like the fifth root of negative 32, because there is a number that when you multiply it by itself 5 times gives you negative 32. And that number is negative 2. Now, if you try doing some more roots of negative 32, like the fourth root of negative 2 and the sixth root of negative 2, you might get something different. So I would encourage you guys to maybe pause the video and just try those on your calculator and see what you get. I'll assume that if you wanted to, you've done that already. So what is the fourth root of negative 32 asking? It's asking what number times itself 4 times gives you minus 32. But if we think about it, whether we have a positive value times a positive or a negative times a negative, those all wind up giving you a positive. Like when you multiply something by itself an even amount of times, you're always going to get an even number. It's actually impossible to get negative 32 when you multiply by an even amount of numbers. So maybe I'll just add a little blurb here. And for the people in my class, this is like a guaranteed communication question on your test for sure. We'll word it this way. You can't evaluate an, we'll say, odd root for a negative number. So you can't do the, you can't evaluate an even root. So you can't do the square root of negative 32 or the fourth root or the sixth root. But the fifth root's okay. You can do that because it's odd. Because you have that negative times negative an odd amount of times giving you a negative number. All right, so now that we've played around with that root button, and hopefully we've now figured out where it is, we can use it efficiently and accurately. Let's do a little mini investigation here. So I've asked you guys to evaluate 4 powers. For each of these powers, the exponent is 0.5. And I just want you to take your calculator, slam these out, and see what you get. You can pause the video if you'd like, and unpause when you're ready. When you do 4 to the power of 0.5, and this, if we think about this, this is kind of weird, right? Like I know what 2 cubed means. To cube something means you multiply itself by itself 3 times. How can I multiply 4 by itself half a time? That kind of seems weird. 4 to the power of 0.5 gives you 2. You can check that out in your calculator. Now, you might be thinking, well, 4 times 0.5 is equal to 2. So do I just get half the number? Well, let's try with 9 to the power of 0.5. You're not going to get 4.5 here. 9 to the power of 0.5 is actually 3. 16 to the power of 0.5 is 4. I'm assuming you've tried these out. Now, 10 to the power of 0.5 doesn't give you a whole number. I got about 3.16. And hopefully after A, B, and C, you might be seeing a pattern there. D does fit that pattern, but see if you can think on what it means for that exponent of 0.5. What does that actually mean? All right, now if you think you got it, just keep that in your back pocket. And if you're not sure yet, well, I'm going to convince you right now. So let's do another little mini investigation, and I want you to evaluate the root of 4 times the root of 4. Now, we can probably go right to the answer here. I'm going to show a step though. Like the root of 4 is 2. The root of 4 is 2. And 2 times 2 is 4. The root of 4 times the root of 4 is 4. Now, most of you could probably have just figured that out, because that's the very definition of square root is what number times itself gives you 4. Well, that would be the root of 4. But if we also look at this a different way, in part B, 4 to the power of a half times 4 to the power of a half. Or if you'd like, 4 to the power of 0.5 times 4 to the power of 0.5, like we had above. We have reviewed our exponent rules, our basic exponent rules from grade 9. When we are multiplying 2 powers together, we add the exponents. And when you add a half and a half, or when you add 0.5 and 0.5, you get 1. And 4 to the power of 1 is equal to 4. So think about this. The root of 4 times itself gives you 4. 4 to the power of a half times itself also gives you 4. The connection is that the root of 4 and 4 to the power of a half are the same thing. And I could have done this with any base. I didn't have to choose 4. I get the same result. The exponent of a half means to square root. And if you go back to the ones we did above, and since I have some space, I can just tuck this in. Yeah, the root of 4 is equal to 2. The root of 9 is equal to 3. The root of 16 is equal to 4. And the root of 10 is not something I have memorized, but I am 99.999% sure that when you do the root of 10 on your calculator, you'll get about 3.16. This is how we can interpret an exponent of a half or 0.5. It means square root. So key idea is this. I have a lot of space for this, not sure why. But you guys can jot this down in this box. The key idea is that if you have some base to the power of 1/2, that just means it's equivalent to square rooting the base. So it's a pretty neat rule. Just maybe off to the side. I will, you know what, I think I'll save that point for later. Let's just continue. So very cool. The exponent of 1/2 means square root. But what about other exponents that are fractions or decimals? So I have a similar example here, looking at the third root of 27. Now, again, this one, you can probably just write down the answer to, but I'll show a step here. What is the third root of 27 times itself 3 times? Well, the third root of 27 is 3. So this is like 3 times 3 times 3, and this is equal to 27. Hopefully you can see how we could have just went right there, because by the very definition of what the third root means, when you take the third root of 27 and you multiply it by itself 3 times, you should get exactly 27, and we do. Oh, and you know what? This mistake I have every single year. I point this out and I never fix it. So we should have 27 to the power of a third times itself 3 times. But what is this equal to using our exponent laws? Well, a third plus a third plus a third just makes a whole. And 27 to the power of 1 is 27. So think on this. If the cubed root of 27 times itself 3 times gives you 27, and 27 to the power of a third multiplied by itself 3 times also gives you 27, that means they're equivalent. And that 27 to the power of 1 over 3 is the third root of 27. So we have now shown that an exponent of 1/3 means the third root. Now, in my opinion, doing another example for the 4th root, 5th root is a bit overkill. I think at this point, hopefully you're convinced of the following. And we're going to generalize this rule to not just a third, but to any, like a 4th, a 5th, a 6th, like this, and so on. The rule is this: a to the power of 1 over n is equal to the nth root of a. So hopefully you're convinced of that from our little investigation. Now, I will now put this to the side. I was going to do this earlier, but didn't want to steal my thunder. When you have an exponent of 1 over 2 and you use this rule, it's not incorrect to write the square root of a like this with a little 2 tucked in there. But we usually just write that as root a. When there's no number in there, we assume it's a square root. So just a little point there. You don't need to write the 2 in, but it's not wrong if you do. And I should also point out that this n is not, it's not multiplication. It's just part of the notation. It's like tucked in there with the square root, little small n tucked in there. It's telling you to do the nth root. It's not n times the root of a, it's the nth root of a. All right, let's give our new rule a spin. So 16 to the power of 1 over 4. So using our new rule, we would write this as the 4th root of 16. And then we can use our calculators. The 4th root of 16 gives you exactly 2. Now I should point out, your calculator, if it's most calculators, scientific ones, you can put 16 to the power of 1/4 in. You have fraction buttons, you can use brackets. You can just plug that into your calculator and get 2. But that doesn't demonstrate to me that you've learned anything. So when you guys are doing practice, assignments, tests, etc., you want to demonstrate that you understand this rule, because anybody can just use a calculator. The goal of this is for you guys to understand the rule. Now, what about 1024 to the power of 0.1? Well, you can write 0.1 as a fraction. It's like 1/10, right? And writing it like that lets you see, okay, that just means I do the 10th root of 1024, which is equal to exactly 2. Maybe you want to pause the video and try C and D. You can unpause when you're ready. I'm just going to go ahead right now. So 625 to the power of 1 over 2. I know that means I need to do the square root of 2. All right. Where were we? We're doing the 625 to the power of 1 over 2. So using our new rule, that is the root of 625. It's not wrong to tuck in the 2. I'll do it here. Nothing wrong with that. And then our calculators, that gives us exactly 25. Third root of -8. Exponent of, -8 to the power of 1 over 3 is the equivalent to the third root of -8. And it's okay to have that negative base because it's an odd root. Your calculator will give you an answer, and that's -2. All right, so all of the examples we've done have been exponents that were 1 over 2, 1 over 3, 1 over 5, stuff like that. But what if you have a fraction that's not 1 over, it's like 3 over something, like 3 over 2 or 4 over 3, etc., etc. How can we handle those? Well, we can just combine rules that we already have. I'm going to show you guys how we can evaluate 4 to the power of 3 over 2, two different ways by using our power of our power rule and our new stuff from today. So let me show you the one way. So 4 to the power of 3 over 2, we can use our knowledge of powers of powers and multiplying fractions to actually rewrite this as 4 to the power of 1 over 2 to the power of 3. So just digest that for a second. That works because power of power, you multiply the exponents, and 1/2 times 3 is 3/2. So those two things are equivalent. And writing it this way now gives us a way to actually evaluate it. So the 2 on the bottom means we're going to be doing the square root of 4. And the 3 on the top means after doing that, we'll raise it to the power of 3. So I'm showing a lot of work here, but it's 2 to the power of 3, and we get 8. Now, this wasn't the only way to do it. A second way to write this would have been to do 4 cubed and then raise that to the power of 1/2. That's the same idea. 4 cubed is equal to 64. So you do the cubed first, and then you do the exponent of 1/2, which means to do square root. And we do root 64, and you can see we get 8 both ways. Now for me, I prefer this method. I prefer this method because by doing the root first, usually you make the numbers smaller and more manageable to work with. By you doing the power first, that usually makes things bigger and you just have larger numbers to work with. So I usually prefer method 1. And from now on, I will use method 1. And the rule I have for you guys for evaluating fraction exponents in general kind of makes use of that first method. So we'll write it down in general terms like this. A to the power of m over n is equal to, so the n, I think I can make those a bit bigger, m over n. So you have an exponent that is a fraction, and the number on top isn't necessarily 1. What can you do? Well, you can think of it this way. The number on the bottom tells you which root to do. We're going to do the nth root of a, and the number on top tells you what to raise that by, what exponent to raise that by. Raise it to the power of m. So the n tells you kind of which root to do, and then the m on top tells you kind of in general what exponent to raise it to. Okay, so let's give that a try. And then we'll also kind of mix in our rules for negative exponents the previous day. So 27 to the power of 2 over 3. So how would you handle this? So you just simply look at the bottom number. It's a 3, which means we're going to do the third root of 27. The 2 on top just means after you do that, raise that to the power of 2. Everybody can do this. I'm quite confident the third root of 27 is 3, and 3 squared is equal to 9. We've got it. And maybe I just have, since I have some extra space up here, maybe let's just tuck in one more example up here. Let's do 4 to the power of 7 over 2. Maybe you want to pause the video and try this one at home. I'm going to continue on though. So what does this mean? 7 over 2. The 2 on the bottom means I'm going to square root 4. And the 7 on the top means I'll raise that to the power of 7 afterwards. It's 2 to the power of 7. 2 to the power of 7 is 128, I believe. Okay. Now, we're going to mix in some rules from previous days where we work with negative exponents and when the base is a fraction. So don't let part B intimidate you. We'll just use the rules that we've been learning. So one thing I note is not only is the exponent a fraction, but it's negative. You should deal with the negative exponent first. I'll add a little note here. Deal with negative exponent first. That's not something you have to do, but it's something that will probably help most people. And our rule for negative exponents was just to flip the base and then change the sign of the exponent. So if we do that with part B, the flip of 1 over 9 is just 9, right? Like 9 over 1. And then we change the exponent to a positive 1 over 2. And just applying that rule for negative exponents made this a lot more manageable. This is just equal to the root of 9, and I know the root of 9 is equal to 3. Now, a question like part C has basically everything we've done working with exponents up to this point. The exponent is negative. It's also a fraction, and the base is a fraction. But again, let's just systematically go at this. We have a negative exponent. We'll deal with that first. We know how to do that. We just flip and change the exponent to 3 over 2. Positive 3 over 2. Just change the sign. And then we apply our rules from today. What does the 2 on the bottom mean? It means we're going to do the square root of 4 over 9. And the 3 on top means we'll raise that to the power of 3. And the rest we can probably do with mental math. The root of 4 is 2. And the root of 9 is 3. Just rooting both 4 and 3. And then we will cube the 2. We will cube the 3. 2 cubed is 8. 3 cubed is 27. 9 over 4 to the power of negative 3 over 2 is equal to 8 over 27. And really, that just basically ticks all the boxes. I cannot cook up something more challenging than that for you guys in terms of evaluating a single power. And I think these 3 questions kind of summarize what we've done today quite well. Later on today, at least if you're in my class, you'll get an opportunity to do quite a bit of practice getting used to these new rules. But I did want to show you guys an application of these fraction exponents. So there's many different ones. A lot of the applications I know anyway come from biology. Now, I stopped taking biology after grade 11. It wasn't my thing. I teach math and physics, and there are a few applications in physics that I'm a bit more I understand a bit better. But yeah, one application of exponents that are fractions, it has to do with animals' metabolic rates. So just in general, like the smaller an animal gets, the faster its heart beats, the more it needs to eat compared to its body weight, because their little hearts are just beating so fast, they're burning through all those calories, so their metabolic rates are bigger. Like a tiny little mouse will have a really, really, really high metabolic rate, whereas like a human being or larger animals, a lot slower metabolic rate. This equation we have here gives us a way to compare the sizes of 2 animals with their metabolic rates. So R1 and R2 are the ratio of their metabolic rates, and M2 and M1, that's the ratio of their masses. And note they're kind of flipped. So let me walk you guys through an example. We'll compare the rates of a 70 kilogram man and a 15 kilogram dog. Let's write it this way. So the metabolic, let's call R1 the dog. It'll have a higher metabolic rate because it's smaller, divided by R man. I'm expecting a number bigger than 1 here. The dog should have a higher metabolic rate than the man. Is it twice as much? Is it 5 times as much? Let's do the math. And the equation says we're going to take the mass of the man divided by the mass of the dog and raise that to the exponent 3 over 4. And so we'll plug those in because we have the masses. 70 over 15 to the power 3 over 4. Now, 3 over 4 works out to exactly 0.75, you really could just put this into your calculator, 70 divided by 15 raised to the power of 0.75, and you'd be done. I think it's a good exercise for us to apply the rules we've learned. So I think there's no harm really in dividing 70 divided by 15. Gives you 4 2/3. I'm going to write about 4.67 to the power of 3 over 4. And yeah, let's just apply our new rule. That's the fourth root of 4.67, and then we cube that. The fourth root, I think it's the first time I had to use this button today because I've just been doing mental math. Fourth root of 4.67, I got about 1.47, and then I'll raise that to the power of 3, squeezing this in here. So I got about 3.2. So what does this mean? This means the metabolic rate for a dog is about 3.2 or 3 times as fast as for the man. So you can think about that in terms of heart beating a lot faster, how much they have to eat to keep providing that energy. But yeah, about 3.2 times as fast. All right, I'm just gonna maybe conclude that with a little sentence here. The rate for the dog is 3.2 times more than the man. We'll just wrap it up that way. Okay, big goal today though is for my students to be able to apply this rule for fraction exponents. You see an exponent that's a fraction, you can apply the rule, turn it into something where you're using roots, and then use your calculator to evaluate. All right, hope you enjoyed. Hope you guys are doing well. Take care, and we'll see you soon.